Hello, I would like to tell you how we calculate the finite Nc corrections in the next to leading order Balitsky-Kovchegov equation using the Gaussian approximation. We work within the color glass condensate effective field theory, where Wilson lines are the basic building blocks. These enter cross-sections explicitly within correlators, and the evolution in rapidity of these correlators is governed by the Balitsky hierarchy, or equivalently the Jim-Walk equation. The hierarchy is an infinite set of open equations, open in the sense that the order n equation requires input from order n plus 1 correlators. The first equation in the hierarchy leads to the pK equation, which governs the evolution of the dipole correlator. We can use the large Nc approximation to calculate any higher order correlators. And in this approximation, a product within a correlator factorizes into a product of expectation values. But we would like to go beyond this limit. We study the pK equation at next to leading order. This contains a leading order-like piece and a next to leading order-like piece, which is what we focus on. And in this next to leading order-like piece, correlators contained are 6-point correlators, which we need to study. How we do this is using the Gaussian approximation, and this allows us to go beyond the large Nc limit. The Gaussian approximation truncates this infinite hierarchy of evolution equations by parametrizing a correlator according to this equation. So in here, we stick in our 6-point correlators that we wish to study, and then we effectively operate with two Lie derivatives, which act to add gluon emission and absorption vertices. What we have found for our 6-point correlators is that it's possible to find a non-trivial basis such that the transition matrix, which is everything here, block diagonalizes nicely into 3 pieces. The bottom 2 pieces give the already known 2-point and 4-point correlator parametric equations. What is new is now we have parametric equations for our 6-point correlators, which we once found analytically, implement numerically, and this is our main result. We have at the bottom the leading order pieces in red at finite Nc and blue at large Nc, and then the next leading order like pieces in the NLOBK equation at finite Nc in red and large Nc in blue. Now here I show the dipole amplitude as just the difference between the finite and large Nc. At the bottom, we have the leading order piece, and at the top, the next to leading order like piece. And the main conclusion from our study is that although we expected a 10% correction from the finite Nc pieces at next to leading order, what we actually found was only about a 1% correction, which is more or less the order of the leading order piece. So thank you for watching.